Hello learners, once again I welcome on the class of transportation engineering. So I hope you all are safe and doing well. So in the previous discussion we have seen how to in introduction part we have seen the 3 years plan, first 20-year road plan, second 20-year road plan and third 20-year road plan. And after that we have seen how to compute the road of length of roadway by third 20-year plan, and after that I have discussed the geometric design, and in the geometric design I have discussed the various parameter like coefficient of friction, lateral friction, longitudinal friction and lateral friction, and after that I have discussed what is camber and what is the different types of camber, and after that I have discussed what is the different types of camber, different types of value suggested by IRC for the different types of camber. So today I will discuss very important topic, that is side distance. So in this lecture I will discuss how to compute the stopping side distance, and after that I will recommend the value of stopping side distance for various lane, like for 2-lane 2-way, 2-lane 1-way and 2-lane 2-way. So today I will discuss about the side distance. Side distance is the length of road visible ahead to the driver from a specified height above carriageway to safely stop the vehicle before collision. Side distance is also known as absolute minimum side distance or non-passing side distance. So if I, this is our vehicle, and this is the driver height. According to IRC it is 1.2 meter, and this is our object. Height of object according to the IRC is 0.15 meter. This is the object, and this is the distance is the stopping side distance. Stopping side distance is the sum of stopping side distance is the sum of lag distance plus braking distance. So stopping side distance is the sum of lag distance plus braking distance. So what is lag distance and what is braking distance? So lag distance is the distance traveled during total reaction time, and the total reaction time according to Indian Road Congress is 2.5 second. So lag, next heading is lag distance. Lag distance. Distance traveled during total reaction time. And the total reaction time according to IRC is 2.5 second. So lag distance is equal to velocity into time. speed of the vehicle into time. Total reaction time I have discussed. Total reaction time, and this total reaction time is divided into, one is called perception time, and the second one is brake reaction time. PIV theory. What is PIV theory? I will discuss. Before that, firstly I will discuss what is perception time. So perception time, the instant we see any objects and think of applying the brake, the time lost is perception time. So what is perception time? Perception time. Perception time is defined as instant we see any object and think of applying the brake. The time lost is perception time. And as I told you, total reaction time is the sum of perception time plus brake reaction time, and the sum of this time is generally taken as 2.5 second. So what is brake reaction time? Brake reaction time instant we think applying the brake to the instant brakes are efficiently applied. So instant we think of applying the brake to the instant brakes are efficiently applied. So this is called brake reaction time. So before I will start, as I told you that stopping side distance is the sum of lag distance and braking distance. So lag distance, as I have discussed, it is the speed of the vehicle into time. Similarly, brake distance, and before that I am going to discuss what is PIV theory. So PIV theory. PIV, the P means perception. I for intellection, E for emotion, and V for volition. So these four parameters: perception, intellection, emotion and volition, and on these four parameters our time, total reaction time, depend. Perception time is the time lost in perceiving any object. Time lost in perceiving any object. Intellection time means time lost in understanding the situation. And emotion time means time lost in fear or anger. Time lost in fear or anger. And volition means time lost in final action. Time lost in final action. So perception time, intellection time, what is emotion time and what is volition time, I have discussed. So this is our PIV theory. This is our brain. So in brain it will come intellection and emotion. This is P and this is volition. Spinal cord or nervous system. So if I compute the braking distance, because the sum of lag distance and braking distance is the stopping side distance. So if this is the two vehicle, initial and final motion of the vehicle. So this is the L distance apart, and this is the weight of the vehicle. Velocity is V. Here velocity is 0. The force is acting F into W. So change in kinetic energy is equal to work done. So the change in kinetic energy is half mv square minus 0 is equal to work done is F into W into L. So half mv square is equal to F and W is m into G into L. So the expression of lag distance is L is equal to V square by 2G into F. So here V is the velocity or speed, G is the acceleration due to gravity, and F is the longitudinal friction. The value recommended by IRC is between 0.35 to 0.4. So the total side distance can be written as stopping side distance. SSD is the sum of lag distance plus braking distance. So stopping side distance is equal to V into T plus V square by 2G into F. So this is the expression of stopping side distance. Where P is the speed in meter per second. So entire transportation engineering I will use velocity in meter per second. T is the total reaction time, I will use in second. If in the question reaction time is not given, then we have to take 2.5 seconds. F is the coefficient of longitudinal friction. G is the acceleration due to gravity. So there is a relationship between acceleration A, length L, time T, coefficient of longitudinal friction F, and acceleration due to gravity G. So what is the relation? So in 9th class of physics, if I apply V is equal to U plus AT, where V is the final speed, U is the initial speed, A is the acceleration, and T is the time. So final speed is 0, so U plus AT we can write, or we know that V square is equal to U square plus 2A into S, here is L, so V square minus U square is equal to 2AL, and V is 0 means minus U square is equal to 2AL, and with the help of U is equal to minus AT, so we can write minus A square T square is equal to AL can also write U square is equal to 2AL, or U square is equal to 2 G into FL. So 2AL is equal to 2GFL. So we can write F is equal to A by G. F is equal to A by G. So coefficient of longitudinal friction can be written as A by G, where A is the retardation in A is retardation in meter per second square. So I am going to discuss effect of gradient on braking distance. Let us assume this is the our road, which is angle of theta. This is the vehicle, speed v. So this is the value of, this is w, this angle is theta, so we can write w cos theta, and this value is w sin theta. So the speed on this direction is f into w sin theta. So once again I will apply change in kinetic energy is equal to work done. So change in kinetic energy, change in kinetic energy is equal to work done. So 1 by 2 m v square minus 0 is equal to L into f w cos theta plus w sin theta. So half mv square is equal to L into, if I take w common, so w is equal to mg, so it is f cos theta plus sin theta. And we know that tan theta is equal to sin theta by cos theta. So when theta is equal to 0, cos theta is approximately equal to 1. Means we can write tan theta is equal to sin theta. So from equation 1 we can write half mv square is equal to L into mg f cos theta plus sin theta, or we can write half mv square is equal to L into mg f plus tan theta, or L is equal to v square by 2g f plus tan theta. So this is the expression of braking distance. Or we can write L is equal to v square by 2g f plus x percent, where x percent is the gradient, or we can write L is equal to v square by 2g f plus n by 100, where n is the gradient. So for up gradient it is using, I will be use plus, and for the down gradient it will be negative. So the general formula if I write for the stopping side distance, so it will be for braking distance L is equal to v square divided by 2g f plus minus n by 100. or tan theta, that will be equal to the gradient, where n is the gradient in percentage. Plus sign is used for up gradient, or negative sign is used for down gradient. So to overall expression of the stopping side distance is equal to lag distance v into t plus v square by 2g f plus minus n by 100. So this is the final expression of stopping side distance when the gradients are taken into account. If tan theta is equal to 0 and let B is the braking efficiency. So B is the braking efficiency, so stopping side distance can be written as V into T plus V square by 2G into F into B, because tan theta is 0. Where B is the braking efficiency. Or we can write, if tan theta is not equal to 0, so stopping side distance is equal to Vt plus V square by 2G F into B plus minus n by 100. So this will be the expression where n is the gradient, already discussed. If braking efficiency is 100%, then expression will be same as Vt by V square by 2G F plus minus n by 100. So for single lane one way, stopping side distance is same as for single lane one way. So three cases are there: case and stopping side distance. So for the first case, single lane one way, in that case it will be same as stopping side distance you will be calculated. For two lane one way, it will be 2 times the stopping side distance. 2 times the stopping side distance. And for two lane two way, it will be same as stopping side distance. So let us take one example. Calculate stopping side distance or minimum sight distance to avoid head-on collision of approaching from opposite side. Approaching from opposite direction at a speed of 60 km per hour and 90 km per hour. Take the value of f is equal to 0.35. So calculate the stopping side distance या minimum side distance to avoid head-on collision of two cases approaching from opposite direction at a speed of 60 km per hour and 90 km per hour. We have to take f is equal to 0.31. So when v is equal to 60 km per hour, or if I convert in meter per second, so just 60 by 3.6, so it is 16.67 meter per second. So stopping side distance is equal to vt plus v square by 2gf, because there is a no gradient. So 16.67 time is not given, so total reaction time is 2.5 plus 16.67 divided by 2g, 19.62 into f is 0.35. So it is coming 82.14 meter. Similarly, for the second velocity, when v is equal to 90 km per hour, so if I convert in meter per second, so 90 by 3.6, so it is 25 meter per second. So stopping side distance 2 is 25 into 2.5 plus 25 by 2g, 2 into 9.81 is 19.62 into time is, sorry, friction is 0.35, so it is coming 153.39 meter. So the stopping side distance or minimum side distance is the sum of SS D1 plus SS D2. So the 82.14 plus 153.39. So it is coming 235.65 meter. Is the total stopping side distance. So dear student, today I have discussed about the stopping side distance, which is the sum of lag distance plus braking distance. So lag distance is the is equal to v into t, where v is the speed of the vehicle and t is the reaction time, and according to Indian Road Congress, the value of reaction time is 2.5 seconds if it is not given in the question. Otherwise, if whatever is given in the question, we have to take the time. And the braking distance, so braking distance, the expression of braking distance I have derived, that is v square by 2gf, where v is the speed, and in transportation engineering I will take the velocity in, everywhere in meter per second and time in second. So take care, so be careful by opting the velocity and time by unit wise. So we have to take the velocity in meter per second. In question it will be given in the kilometer per hour. So we have to convert by just dividing by 3.6, we will get the velocity in meter per second. So the expression of braking distance is v square by 2gf. So overall expression of the stopping side distance is vt plus v square by 2gf. After that we have derived the we have taken the effect of gradient, and the expression of the stopping side distance is vt plus v square by 2gf plus minus n. For upgrade it is positive, and for downgrade the value is taken as negative, where n is the gradient. And after that I have suggested for single lane the stopping side distance is SSD, and for two lane one way it is 2 times the stopping side distance, and for two lane two way it is stopping side distance. And after that one problem I have taken. In the subsequent class I will discuss what is the overtaking side distance and what is the expression of overtaking side distance. So take care of your health and happy learning.